I have connected input-output extension modules to Finder OPTA controller. Now I can scale my industrial application and write complex programs. In this video, I will show you how to configure extension modules in PLC IDE environment and how to connect Finder OPTA using wireless Wi-Fi network to exchange data with a cloud application like Arduino Cloud. I have connected a heater and a ventilator. I will use those devices to create a simple temperature controller program. You can use such a program in any control cabinet. If you enjoy content about programming industrial automation, just hit the like button down below the video and subscribe to our channel to more content. Let's get started with this video. What does the configuration of the Finder OPTA controller with extension modules look like? I added a module with 16 digital inputs and 8 digital outputs to the controller, with SSR relays with a current load of 2 amperes. The next module is 16 digital inputs and 8 outputs with electromagnetic relays with a current load of 6 amperes. How to add such modules to the controller? On the right side of the Finder OPTA, there is a cover called aux. You need to break this cover, and here you will see a connector to which you can add more extension modules. What does the configuration look like for my test setup? Each module must have its own external 24 volts DC power supply. Here we have the input. Here I connected the stop button to the first module, then the start button to the input, and I used the outputs for the ventilator, the heater and the lighting. The Finder OPTA has its own 3D model in the SolidWorks electrical environment. We use this environment in our company to design electrical diagrams, and based on this we design 3D models of control cabinets. We can add such a model of the Finder OPTA. I will make all the connections and see how it works in real control cabinet. We'll definitely use such a model in our future projects. I created a new project in PLC IDE. Now I will show you how to configure extension modules for Finder OPTA. The first thing you need to do is of course connect to the controller. Here I am connected via USB cable. I choose the Modbus option here. If you go to Properties, here I have detected 2 serial ports, COM9 and COM10. You select OK and you click on the Online and Connect option. I'm connected to the controller. Now I go to the new tab in the PLC IDE, which is I/O Expansions. Here I select the Scan option, and 2 extension modules have been detected, which I have added to my mounting plate. And I click on Apply Detect Config. The modules appeared in the project tree. Let's check it out. Here is an elegant view of the individual modules. The first module is an input-output module, and here we have output with SSR relays, 2 amperes. The next module with electromagnetic relays, 6 amperes, so we have here a higher current load. Now I will add variables. I go to the first module, to the Programmed Inputs tab. Here I declared the XPB stop button. This is a button with normally closed contacts. I connected this button to the input of the first extension module. I go to Relay Outputs. On the third output I connected the signal light, the lighting of my control cabinet, and I name it X light. I go to the next module. On the second input I connected the start button with normally open contacts. On the third output I connected the ventilator. X ventilator variable. On the last output I connected the heater. That's all. As you can see, mapping these modules is as simple as mapping Finder Opta controller input-outputs. We have here local I/O mapping. Here I added more variables, for example analog value reading. I also have lights that indicate the operation of the ventilator and the heater, leg backlight built in the Finder Opta, and user button. Now I will go to a very important configuration. I will connect the Finder Opta to a wireless Wi-Fi network to exchange data with a cloud application. So I go to app.arduino.cc to the Devices tab and click on Add Device. Make sure your controller is connected via USB-C cable to your computer. Here you select Arduino board. After a while, you will be connected to the Finder Opta. Here I choose, for example, COM9. The firmware is being checked, and soon I will be able to configure this device in the cloud. We name our device. I name it ControlByte, and I will click Next. And here we can connect via Ethernet or Wi-Fi. Of course, I choose Wi-Fi connection. The configuration sketch program is being uploaded now. Okay, congratulations, you have managed to configure this device. Click on Done, and a dashboard for this device is displayed. Let's return to the main screen and select the Things option. We create a new thing. We need to correlate the device with the configuration. Click Associate, which is our device named ControlByte. And now I can configure the network. I select the connect directly to my Wi-Fi network. My SSID is ControlByte. I enter the password and click Save. At this point, it is worth adding a few more cloud variables. Okay, we have the variables that I will exchange in the dashboard. I will go to the Sketch tab. After a while, I should be connected to the device via USB-C cable, and this script needs to be uploaded. We also have the thing properties.h file. Here we have all the variables we declared, and also functions for individual variables, as well as the encrypted key for the Wi-Fi network. These codes need to be uploaded, so I click on Upload, and that's all. The configuration has been uploaded, so now we go back to PLC IDE. Here in the project tree, in the Resources tab, you will find such a tree, Shared Variables. And here you can add, for example, the xLight Cloud variable. This variable will be exchanged with the cloud application. As for the outputs, of course, we'll add here X Heater Cloud and X Ventilator Cloud. And let it be I Temperature Cloud. Of course, remember about types of variables. It will be a bool variable, integer, bool, and bool variable. However, that's not all, because we need to add a few more libraries. If you go to the Libraries tab in the Sketch field, here I added a few libraries. The list of libraries, of course, is below this video. There is, among others, the Arduino IoT Cloud library, MQTT client, and all libraries have specific versions. These versions are saved in the project. The next thing I did here is modified my sketch configuration file. See what happened here. First of all, I included the Arduino IoT Cloud library and Arduino connection handler. I provided the password and log into my Wi-Fi network. I have here further functions for individual variables, and this sketch is simply copied from the sketch generated in the cloud. The part for the variable password is copied, and the same goes for init properties. See that I have copied it. And further, I have the setup, which I also copied and added to my sketch. The most important thing, I also have functions that correspond to the behavior of my cloud variables. And here, for example, I have the xHeater variable, which is mapped to my extension modules. I might show it again. xHeater is mapped to the extension modules. However, in the sketch, the value passed out from the cloud shared variables is written here. I have the variable ventilator mapped to the extension module's temperature, and here, conversely, the xLight variable is written to the cloud variable. Note that the behaviors of individual variables are written within individual void functions. These functions are then called in the loop. So I had to perform a few operations to make everything work and connect to the cloud. This ready script is uploaded to our Finder OPTA memory and we can start working. That's all in this video. Now you know how to use extension modules with Finder OPTA controller. Subscribe to our channel for more automation content and write the comment down below the video what would you like to see on our channel regarding Finder OPTA. See you in the next video.